All right. So once again we will continue from where we left off. So in this case, we are trying to find the relationship between the direction vector and the gradient of a line. Now, if you recall, in our last video, I mentioned that in SHS or in your previous schooling, when you want to find the equation of a line, you need what? A gradient and a point. Your gradient tells you the direction of what? Of a line. So if your gradient is positive, it tells that what? It's sloping upwards. The gradient is what? Negative, tells that it's sloping what? Downwards. So it was essentially giving you the direction of the line, right? In some way. Now, in this course, we are interested in finding out the vector equation of a line. So we are interested in using a direction vector and what's in the point. Now your direction vector acts like the gradient, so the direction vector also tells you the direction of your line. So it tells you the direction that your line have taken. So your direction vector is just any vector that is parallel to your line. If it's parallel to it and you know the direction of that vector, you can know the direction of your line, right? Now in here we are trying to prove that there is a relationship between us, your direction vector and the gradient, and actually that relationship is given us what? I plus what? Mj. We are saying that your direction vector is the vector I plus the gradient of what? The plus the gradient, right? So the gradient is the more like the second component of your direction vector. Now the question is how and why. Okay, now if you recall, if I know, let me draw this, right? So I have 2 points of a line. Let me call this point let me call this point B, let me call this point A, right? Now point A is some x1, y1, your point B is some x2, y2, right? Now what do we know about point AB, right? Now your point AB, or sorry, the vector AB is the direction vector of what? Of this line, that's B minus A. So if I do B minus A, essentially what I'm going to get s2 minus x1 I plus y2 minus y1 j. So that means there's one. That means my direction vector is given us what? X2 minus x1 I plus y2 minus y1 j. Okay, all right. Now let me call to make my work simple. Let me call this change in x, right? Let me call y2 minus y1 change in y. Now if you recall in SHS, your gradient, let me write that one here. Your gradient is actually giving us some y2 minus y1 over x2 minus x1. That's the same as changing y while you're changing x. That's what your gradient. That's how you find your gradient, given 2 points, right? So it means my direction vector now is going to be changing xi plus changing yj. Now if I factorize changing x out, what do I get? I get changing x into bracket I plus changing y over changing x j. Okay, so now what is changing y over changing x? That's my gradient. So I'm saying that my direction vector here is now parallel. My direction vector is parallel to this line, or this vector I plus what? Mj, meaning it's a scalar multiple of this line. Your changing x is just a number, a scalar. That's s2 minus s1. They are points, so the difference just gives you a scalar. So it means my direction vector is parallel to the vector I plus mj. Now if you have your direction vector to be parallel to another vector, this I plus mj, it means that this I plus mj also gives you the direction of this line. So even if you don't know the actual direction vector of the line and you know the gradient, it means that your direction vector will be parallel to this vector, which is actually your gradient vector. Let me call it your gradient vector. So it means that you can use this vector I plus mj as the direction vector of your line. Now also, you also know that your direction vector is a scalar multiple of this, right? Now we are always interested in the simplest form. So in here, this is the simplest form of the direction vector. So it means your direction vector is actually I plus mj. So if you have a gradient and if you have a gradient, you can find out the direction vector of your line. So given a gradient and a point, you can still find out the vector equation of a line. Okay, let's take one example. Let's m, which is the gradient, which is minus 4 over 3, be the gradient of the line passing through the points A, which is 2, 1, minus 2, 1. Find the equation of this line. So you know that your direction vector, you can just go straight to the point. Your direction vector is I plus mj. And so your direction vector is just I minus 4 over 3j, right? Now you can use this as your direction vector, but it doesn't really look nice. So what we are going to do is we are going to restructure it into, let's find the LCM. The LCM is 3. Then we get 3i minus what, 4j. And since we are looking at the simplest form of the direction vector, this is the same as 1 over 3, 3i minus 4j. We just take out the direction vector d to be 3i minus 4j, because we're always interested in what the simplest form. That means the equation with line is just giving us some r. It passes through this point, so that's the point 2i plus j plus some parameter, let me call mu of 3i minus 4j, and this will represent what the equation with the line. Very simple. So I'll advise you guys to try your hands on some of the examples or the questions in the exercise 1. You can see some of these questions, so try your hands on them. And please like our video, share and subscribe. Thank you very much.